Hi, I'm really excited to show you a demo of the memory deduplication feature in the WoolyAi GPU hypervisor, a breakthrough that can dramatically increase video RAM capacity. But before the demo, let me give you a quick introduction to our GPU hypervisor. WoolyAi is a GPU hypervisor we built to transform how ML workloads run on NVIDIA and AMD GPUs. It delivers three big benefits: unified containers. Run the same CUDA containers on both NVIDIA and AMD GPUs, with no code changes. Separation of user and GPU execution space. Your ML containers can run remotely on CPU-only infrastructure, while GPU kernels execute on the hardware. Dynamic GPU resource management. WoolyAi allocates compute cores and video RAM across workloads to maximize utilization and eliminate waste. In practice, this means more workloads per GPU. So, how does it all come together? The WoolyAi client container runs your PyTorch projects or inference apps like VLLM. Inside, our just-in-time compiler translates CUDA kernels into the WoolyAi instruction set. These kernels are then sent to the WoolyAi server on the GPU node, where they're translated into NVIDIA or AMD native instructions, while keeping hardware-specific optimizations. This makes the pipeline portable and unified, with performance close to running natively. Meanwhile, the WoolyAi controller decides which GPU in the cluster to connect to, based on utilization, job priority, and resource needs. Because the WoolyAi server controls execution in the GPU space, it can run kernels from multiple processes inside a single context, dynamically allocating compute cores and video RAM. This enables true concurrency, predictable SLAs, and 100% utilization, with no context switching overhead. Memory deduplication feature of the hypervisor is meant to increase the capacity of the GPU when you want to run multiple LoRA inference setup. Let's take a look at how it works. Today, if you want to serve several independent LoRA fine-tunes of one model, you usually dedicate a full GPU to each. That means every GPU loads the base model, the LoRA adapter, and the KV cache separately. This guarantees isolation but wastes GPU video RAM. Another option is to use adapter switching or shared batching, as supported in tools like VLLM or LoRax. But these approaches have real drawbacks: latency overhead from switching, inefficient batching that slows down requests, and no process isolation between adapters, a big problem if you're serving different business units. With WoolyAi hypervisor memory deduplication, you get the best of both worlds. Each LoRA adapter stack runs in its own isolated process. The base model weights are shared once in video RAM. Each adapter manages its own batching independently. That means you can host many LoRA adapters on a single GPU that simply wouldn't fit before, without giving up isolation or performance. Now, let's jump into a short demo to show you how it works in action. First, we are going to see the behavior on native CUDA without the WoolyAi GPU hypervisor. This is a NVIDIA GH200 single GPU host with 97 GB of VRAM. My PyTorch application loads a 13B Llama 2 base model and a specific LoRA adapters and creates an API endpoint. I can use the API endpoint to run queries. We will run it on native CUDA without using WoolyAi GPU hypervisor memory deduplication feature. I am starting an instance of this PyTorch application to run Llama 2 13B code Alpaca Clora LoRA adapter. So, it will load the 13B Llama model and then load this adapter and provide an API point for this inference. We can now see that the available VRAM on the GPU went down from 78 GB to 51 GB because the Llama 13B model in the VRAM, which takes approximately 27 GB. I still have 45 GB VRAM unutilized. Let me now run a simple prompt against my endpoint to make sure it's loaded correctly and working. Let me now start another instance of same PyTorch application with a different LoRA adapter. This time it's Llama 13B Clora UltraChat 2. So, now second copy of the Llama 13B base model is loaded in the VRAM along with the LoRA adapter weights. We can see that available VRAM is now approximately 27 GB, less than what it was before. Utilized VRAM is now 71 GB, which is because a second copy of Llama 13B model was loaded into the VRAM. Let me again run a simple prompt against my new endpoint for this LoRA to make sure it's loaded properly and working. Let's try to start another instance of same PyTorch application with a different third LoRA Llama 213B PEFT and QNORET. The system will try to again load the Llama 13B base model in VRAM. However, there isn't enough free VRAM available now, so we get a CUDA out of memory error. So, we see that we can only run a maximum of 2 instances of independent LoRA application stacks using the same base model Llama 13B before we hit the CUDA out of memory error. This is because the base model is loaded twice into VRAM, resulting in significant VRAM wastage. Next, let's load these LoRA PyTorch applications on Woolly hypervisor running on the same GH200 single GPU node with 97 GB VRAM. I am now going to run the same PyTorch application but inside Woolly container, which you can even run on a remote CPU-only infrastructure with the kernels executing on the GPU host. In this demo, I am not running my Woolly container remotely, but it's running on the NVIDIA GPU host where the Woolly server executes the kernel. I am now inside the Woolly container and have the same PyTorch application which I ran earlier without the Woolly hypervisor. I am starting my first LoRA PyTorch application, and you can see that the base Llama 13B model was loaded in the VRAM. I now have 51 GB of free VRAM. Let me now run a simple prompt against my endpoint to make sure it's loaded and working. Let's load the second LoRA PyTorch application with a different LoRA adapter and the same base model Llama 13B. When this application loads, you see that the incremental increase in used VRAM is only 845 MB, which is for the LoRA model weights and not the entire Llama 13B model. This is because the Woolly hypervisor did not load a second instance of Llama 13B in the VRAM. The hypervisor detected that it's the same model which was loaded earlier with the first LoRA application stack and is now being shared between these 2 independent and isolated LoRA PyTorch applications. Let me again run a simple prompt against my endpoint to make sure it's loaded properly and working. I am now loading a third LoRA PyTorch application with a different LoRA adapter, and we can see that only the LoRA model weights are loaded in the GPU VRAM and not the entire Llama 13B base model. This is the memory deduplication feature working. I still have plenty of free VRAM to load more PyTorch applications. I will run a simple prompt against my endpoint to make sure it's loaded properly and working. I am now loading the fourth LoRA PyTorch application with a different LoRA adapter, and we can see again that only the LoRA model weights are loaded in the GPU VRAM and not the entire Llama 13B base model. I still have plenty of free VRAM to load more PyTorch applications. I will run a simple prompt against my endpoint to make sure it is loaded properly and working. Let's get crazy with this and load more Llama 13B and LoRA application on this GPU. This is so much fun. I am now loading the fifth LoRA PyTorch application with a different LoRA adapter. I will run a simple prompt against my endpoint to make sure it's loaded properly and working. I still have plenty of free VRAM available. I now have 5 instances of Llama 13B LoRA application stacks running concurrently on a 97 GB VRAM GPU serving users, whereas on native CUDA, without Woolly hypervisor, I was only able to load and concurrently run 2 instances of Llama 13B LoRA application stack. This is the magic of Woolly GPU hypervisor memory deduplication. Memory deduplication is just one of many features of Woolly GPU hypervisor. With Woolly GPU hypervisor platform, you can run your ML workloads in CPU-only infrastructure remotely while the kernels execute on GPU nodes. You can create unified container pipelines with no code changes to your CUDA workloads and execute them on both NVIDIA and AMD. And Woolly Hypervisor GPU Resource Management dynamically manages compute cores and VRAM allocation to achieve 100% GPU utilization across concurrent heterogeneous workloads. For more information, go to WoolyAi.com. Thank you for your time.